So if you think about the YouTube algorithm, right, it only responds uh, to really aggressive, purposeful action.
Right, yeah. It doesn't care if you're just passively watching.
Exactly. You can't just kind of nod along to a video and expect the system to magically understand your preferences.
Hmm.
As the source for today's deep dive points out with a bit of a wink, actually you can't just casually click the like button.
You have to destroy it.
You have to destroy it, like smash it. You have to be deliberate and forceful and just leave absolutely no ambiguity about what your intentions are if you want the underlying architecture to actually register that you're there.
And that framing completely translates to how we handle high-stakes human systems, too.
Oh, totally.
Because we so often treat professional feedback like a passive scroll. We just leave a vague comment, maybe offer a half-hearted suggestion.
A little looks fine to me kind of thing.
Exactly. And then we wonder why the end product, the actual system we're building with our colleagues, fails to adapt or improve. I mean, the system only responds to intentionality.
Right. And today, we are taking that idea of like hyper-intentional interaction and applying it to a very specific and honestly notoriously fraught arena.
Evaluating the complex work of your peers, which is never easy.
Never. We have a single highly detailed source today. It's basically a masterclass in feedback drawn from a presentation by Cody Engel. He's a staff software engineer, and he has conducted over 1,000 code reviews in his career.
Which is just a staggering number. I mean, 1,000 reviews represents an enormous sample size for human behavior in a really tense environment.
Right, because it's not just reading text, it's a negotiation.
Yeah, think about the sheer volume of conflict, the problem-solving required to process that many peer evaluations. And a staff engineer isn't just a senior coder. They are an architectural leader.
Their job is the big picture.
Exactly. Their job is to ensure the entire system scales, which means their feedback dictates the daily workflow of dozens of other engineers.
And the mission for you, listening right now, is to extract Cody's exact blueprint for what he calls drama-free feedback.
Trauma-free is the dream.
It is. And even if the phrase pull request sounds like a gym exercise to you, the underlying mechanics of this blueprint still apply. Because at its core, this deep dive is about how to evaluate complex deliverables, right? How to communicate critiques without triggering, defensive workplace wars.
And how to maintain a relentless standard of quality when literally everyone is stressed and rushing?
Yes, because everyone is always rushing.
Always. And it tackles arguably the most difficult soft skill in any modern profession. In software engineering, code reviews are not just a final polish to catch typos.
That is not spell check.
No, not at all. They are the primary and frequently the only mechanism for rigorous quality control. And beyond the technical aspect, the code review is the crucible where team culture is actively forged.
Oh, I like that. The crucible.
Yeah, because a toxic review culture where feedback is wielded as a weapon, or people use it to show off how smart they are, that leads to high turnover. Developers start hiding their mistakes, and the whole team gets paralyzed.
Whereas a healthy review culture creates psychological safety. It actually accelerates innovation.
Precisely.
So how do we actually navigate that without the drama? I mean, the most striking element in Cody's breakdown isn't a technical tool at all. It happens before a single line of code is evaluated.
Right, it's the pregame.
Yeah, the pregame.
Yeah.
He argues the entire outcome of the review is dictated by the reviewer's mental state before they even open the file.
The mindset precedes the mechanics. He explicitly emphasizes the necessity of approaching reviews with an open mind and prioritizing a growth mindset instead of a fixed one.
So what does that actually look like in practice? A growth mindset.
In practice, it means acknowledging that your initial assumption about a piece of work might be entirely wrong.
Oh, wow. So going in assuming you might be the one making the mistake.
Exactly. Because a fixed mindset in this context looks like gatekeeping. It's the reviewer assuming they are the sole arbiter of truth, just waiting to strike down the inferior work of their peers.
Which is a terrible vibe for a team.
It's the worst. So Cody dismantles that by implementing this hyper-specific communication rule. Unless he sees something that is definitively, undeniably wrong, he frames his feedback exclusively as a question.
No statements.
He does not use statements.
The psychological pivot there is brilliant, actually.
It really is, because when someone evaluates your work, the default human setting is defensive.
Totally. You immediately tense up.
Right, the dynamic is inherently adversarial. It's like, I'm the reviewer, therefore I am right. You are the author, therefore your work is under suspicion.
Shifting a critique into a genuine question neutralizes that adversarial dynamic instantly. It transforms a confrontation into, like a mutual exploration.
Yeah, you aren't saying you built the support beams on this bridge incorrectly.
You are asking, help me understand the load-bearing calculations that led to this specific beam placement.
Exactly. The defensive shields stay down because you are inviting them to act as the expert of their own work.
Okay, but I have to push back here.
Go for it.
What if the code is just objectively terrible?
Like, beyond saving.
Yeah. If we stick to your bridge analogy, what if the support beams are made of dry spaghetti? Or, I don't know, to step out of tech, think about an editor reviewing a messy manuscript where the author inexplicably changes the protagonist's name halfway through chapter 3.
Right, a glaring error.
Does a gentle exploring question just waste everyone's time in that scenario? Asking, hey, I was wondering if maybe we should keep the hero's name consistent, feels incredibly passive when the house is clearly on fire.
And that is where the nuance of a highly experienced practitioner comes in. Cody isn't advocating for toxic positivity.
Okay.
He's not avoiding hard truths to spare feelings. He maintains a very stark, unsentimental threshold for what constitutes clearly wrong.
So what's the threshold?
If the code has obvious unintended side effects, or if it blatantly fails to execute the task it claims to do, the gentle question goes out the window.
Oh, so he drops the act.
Yeah, if the bridge is going to collapse, you don't casually inquire about the architect's feelings. You flag the catastrophic failure.
So he just comments that it's wrong.
He calls it out directly in the comment, yes. But, and this is the crucial mechanical step, he immediately pairs that written critique with a direct message on Slack.
Oh, interesting. So he leaves the public comment, but simultaneously sends a DM.
Exactly. He'll say, hey, this doesn't look quite right. Can we just chat about this?
He forces a pivot to FaceTime, or at least like a voice or video call.
Yes. He physically removes the conflict from the text box.
Which makes so much sense because text is a fundamentally low bandwidth medium for emotional nuance.
That's awful for that.
When tensions are already running high, which, is the biological reality of telling a professional their work is fundamentally broken, text almost inevitably reads as cold or aggressive.
Or condescending.
Right, because the author's brain fills in the missing vocal inflection with the absolute worst possible tone.
We see this constantly. I mean, think about your own email history or the Teams channels at your job. How many times have you watched a minor disagreement over, like, a spreadsheet escalate into a multi-day passive-aggressive text war? Oh, way too often. People typing literal paragraphs at each other.
Getting more and more dug into their positions entirely because they can't hear the other person's voice. A 5-minute phone call could have diffused the entire situation on day one.
And by immediately offering that call, Cody stops the endless comment thread before it can even spawn.
He restores humanity to the feedback loop.
Exactly. The Let's Chat DM sends a very specific signal. It says, I am on your side, and we are tackling this problem together.
It reframes the review from a bureaucratic hurdle into a collaborative troubleshooting session. I love that.
It's highly effective.
So the pregame is set. We are approaching the work with a growth mindset. We are armed with questions rather than declarations, and we are ready to hit the call button if things go sideways.
Ready to dive in.
So how does the actual mechanical process of the review begin?
Well, Cody admits that when he is swamped with his own tasks, which is most of the time, the overwhelming temptation is to crack open the pull request, the PR, and jump straight into reading the raw lines of code.
Just to get it off his plate.
Exactly. It requires immense discipline to resist that urge. Because when you are a staff engineer, your time is your most precious resource.
But he explicitly warns against giving in to that temptation, right?
He does. Step 1, without exception, is reading the PR description.
And step 2.
Step 2 is skimming the changes, but specifically forcing yourself to start with the unit tests before looking at the core logic.
Okay, let's unpack that. Because skipping the description is honestly a universal failure mode in professional collaboration.
Oh, 100%.
If you dive straight into the raw data or the draft document without reading the author's summary, you are evaluating what is happening with zero understanding of why it is happening.
Right, you have no context.
The author might have spent 45 minutes carefully crafting a description that explains a bizarre edge case they had to accommodate, or like a temporary workaround they were forced to implement because of a legacy system dependency.
And if you bypass that summary, you are flying blind.
You're going to waste 20 minutes writing a long, detailed comment pointing out how weird their workaround is, only for the author to reply, per the description you didn't read, the legacy server requires this format.
Which creates instant friction. And honestly, it destroys your credibility as a reviewer.
Yeah, you transition from a helpful peer to an annoying obstacle immediately.
Exactly. So after digesting the description, Cody moves to the unit tests.
For those not in the weeds of software engineering, explain unit tests real quick.
Sure. In software engineering, unit tests are automated scripts written by the developer to mathematically prove their core logic behaves as expected. You feed the function-specific inputs, and the test asserts that it produces the correct outputs.
Okay, got it. So if you skip the unit test, you are bypassing the very scripts that prove the code does what the author claims it does.
Right.
Attempting to review the main code without reading the unit tests first is like trying to assemble a complex 1,000-piece jigsaw puzzle without looking at the picture on the box.
That is a perfect analogy. The tests provide the blueprint of intent. They reveal exactly how the code is supposed to interact with the real world under different conditions.
So if you analyze those tests first, you have the structural picture in your mind.
Yes. You know what the puzzle is supposed to look like before you start examining the individual interlocking pieces of the core logic.
And Cody notes a really fascinating canary in the coal mine here. He says if the unit tests are confusing or difficult to read, the rest of the code review is guaranteed to be a nightmare.
Oh, inevitably. If the picture on the puzzle box is blurry and distorted, you have no hope of putting the pieces together.
But conversely, this initial skim, digesting the description, validating the tests, and giving the core code a quick structural glance, serves an incredibly practical function.
It does. He states that roughly 80% of the time, nothing alarming sticks out during this initial pass.
80%. That is a massive volume of work that just sails through the initial filter.
It really is. And when that happens, he doesn't go hunting for problems just to justify his existence as a reviewer.
Right. No ego trips.
He approves it quickly with an LGTM looks good to me and stamps it with a ship it squirrel emoji.
A ship its squirrel emoji. I love that.
Hmm.
The inclusion of the emoji is a small but deliberate injection of levity, I think. It keeps the atmosphere light.
Definitely. But the underlying engine of this entire initial phase is what Cody explicitly labels mindfulness.
Which is funny, right? Because we hear mindfulness and immediately picture like meditation retreats and deep breathing.
Right. Yoga mats and incense.
Yeah. But he applies it as a hard tactical skill.
In high-stakes technical environments, mindfulness is simply metacognition. It is the real-time ability to observe your own cognitive state.
It's that exact moment where your brain screams, I'm stressed, my own deadlines are looming, I want to skip the instructions and just look at the raw work. And you have to consciously override that biological impulse.
Yes, you have to forcefully tell yourself to slow down in order to speed up.
Because taking 2 deliberate minutes to read the PR description saves you 40 minutes of confusing adversarial back and forth later in the day.
Exactly. It's an investment.
But let's assume the initial skim actually does trigger a warning flag. The description is read, the puzzle box is analyzed, but something in the code catches his eye. A deeper look is required.
Right. The 20% of the time, it's not a quick approval.
So when a staff engineer slows down and leans in, what exactly are they hunting for on a standard GitHub interface?
Well, he assumes the basic functionality is present, right? Because the unit tests already prove the code executes. What he's zeroing in on now are best practices.
What does that encompass?
It encompasses naming conventions, like are the classes, variables, and functions named in a way that clearly broadcasts their intent to future developers.
Are they readable, basically?
Right. And more deeply, it's about the appropriate use of language-specific features.
Okay, and Cody uses a highly specific example here that I think brilliantly illustrates the vast gulf between basic competence and true mastery.
He does.
As an Android engineer, his primary tool is Kotlin, which is a modern programming language. When he reviews work, he is constantly on the lookout for what he calls Kotlin code written like Java.
And this requires a bit of architectural history to fully appreciate.
Break it down for us.
So Java is a historically dominant, much older, and highly verbose programming language.
It's kind of the old guard.
Exactly. It is incredibly explicit. Android was originally built entirely on Java, but over the last several years, the industry has aggressively transitioned to Kotlin, which is a much more modern, concise language.
It's designed to be faster to write.
Yes, it's designed to eliminate all that heavy boilerplate code that Java requires. Now, the two languages can interoperate, but they possess entirely different idioms and philosophies.
It is exactly the difference between literal translation and native fluency.
Oh, that's a great way to put it.
Like you can take a complex sentence in English and translate it word for word into French. A native French speaker will understand what you are trying to say, but they will instantly recognize that you are not from there.
Right. The phrasing will feel clunky.
Rigid and stripped of all cultural idiom.
Exactly. When a developer writes Kotlin code using a Java mental model, they are dragging the heavy baggage of the old system into the new environment.
They're translating word for word.
Right. They might manually write out tedious data structures instead of using Kotlin's built-in data classes. They might use clunky, explicit checks for missing data instead of utilizing Kotlin's streamlined null safety features.
They are ignoring the highly specialized tools the new language provides. To bring this out of the programming world, it's like watching a colleague open up Microsoft Excel, a profoundly powerful computational tool, and simply using it to type out a static grocery list.
Oh man, I've seen people do that.
Right. They're just using it as digital graph paper. Yes, the tool technically recorded the names, but they are missing the entire architectural point of the software.
They aren't utilizing formulas or dynamic filtering or relational logic.
Exactly. And when Cody spots this digital graph paper, when he sees Java logic forcefully crammed into Kotlin syntax, he immediately deploys his primary weapon.
The motive-free question.
The motive-free question. He asks the developer why they chose that specific architectural path, and then he offers a Kotlin alternative.
He physically shows them how to speak the language fluently.
Kotlin.
Yeah.
The pure native expression of the tool.
I love that phrase.
But he isn't always gently suggesting alternatives, is he? He has hard, non-negotiable boundaries, particularly when it comes to the philosophy of testing.
He does. He highlights a severe anti-pattern in the industry, which is mocking the class under test.
Okay, mocking the class under test. Let's dig into that.
So mocking is a standard practice in software testing. It basically involves creating a fake, simulated version of a system component.
Why do you need a fake version?
So you can see how your new code interacts with it in isolation without having to spin up the entire massive production database just to run one small test.
Okay, that makes sense. But the critical error is mocking the actual thing you were supposed to be testing, the class under test.
Why?
The analogy that perfectly captures this absurdity is a health inspector arriving at a highly rated restaurant.
I love this analogy.
The inspector asks to taste the signature soup to ensure it is safe. But instead of going into the kitchen and ladling a bowl from the actual simmering pot, the chef reaches under the counter, pulls out a plastic, factory-sealed display bowl of fake soup, and hands it to the inspector.
And the inspector just goes along with it.
Right. The inspector tests the plastic soup, declares it free of bacteria, and gives the restaurant an A rating.
Which is madness because, of course, the plastic soup passes the test. It is a fabricated object designed specifically to pass.
In software, developers sometimes mock the class under test because writing genuine tests for complex, messy logic is difficult and time-consuming.
Yeah, faking the core logic ensures the test passes immediately, which artificially inflates the project's test coverage metrics. It pleases management, but it fundamentally betrays the reality of the system.
And when Cody detects this plastic soup, the tone of the review shifts dramatically. He drops the gentle suggestion.
He treats this as a polite but firm rejection of the premise.
Right. He leaves a comment stating, "Heads up, we should not do that," drawing a hard line in the sand while simultaneously offering his time to help them rebuild the test correctly.
That is a masterclass in calibrating authority.
It really is.
He does not shame the junior developer in front of the team, but he leaves zero ambiguity that the practice introduces systemic risk and is utterly unacceptable.
This behavior isolates the core function of a staff engineer, honestly. True mastery of a discipline isn't about hoarding knowledge or simply catching errors to prove how smart you are.
It is about elevating the baseline craft of your peers. You are enforcing best practices so that the collective fluency of the entire team rises.
But elevating a team requires a willing audience. What happens when the original author pushes back?
The pushback.
Because providing a fluent Kotlin alternative is easy, but what if the author replies, "I understand your suggestion, but I actually prefer my Java-style approach"?
Right, what then?
Cody drops a rule here that I found to be the most profound insight in the entire deep dive. He states, unequivocally, if I can't convince the author that they should make these changes, that is my fault. It's not theirs.
That is an incredibly radical standard of humility for a senior leader to adopt.
The burden of persuasion rests entirely on the shoulders of the reviewer.
Think about how aggressively that dismantles traditional corporate hierarchies.
Well, completely.
In a standard structure, the senior director says, change this. and the junior employee complies strictly because of the title on the org chart. It is an argument won by fiat.
Because they said so.
Exactly. Cody completely rejects that paradigm. He is establishing that his staff engineer title does not grant him the unilateral right to force architectural changes simply because he prefers them. He must articulate the why.
He has to win the debate purely on the technical merits of his argument.
And if he lacks the communication skills or the deep technical clarity to explain the why effectively enough to persuade the author, then he has not earned the right to demand the change.
Wow.
This philosophy forces the reviewer to rigorously audit their own critiques before they even type them. You cannot be a drive-by critic, throwing out vague suggestions and expecting blind obedience.
You are forced to act as an educator.
Yes. And that dynamic is the bedrock of a healthy, intellectually rigorous culture.
Let me introduce a major complication into that intellectual utopia, though.
Okay, let's hear it.
What if the code looks incredibly weird and the logic seems convoluted, not because the engineer is stubborn or inexperienced, but because they possess context that Cody doesn't? What if that developer had a one-on-one meeting with a product manager earlier that morning, and there's a bizarre, hidden business requirement that necessitates the spaghetti code?
The specter of hidden business logic. It is the bane of every reviewer's existence, and the source material addresses it directly.
How does it happen?
In large, fast-moving organizations, context is heavily fragmented. Engineers are frequently pulled into side conversations with designers, stakeholders, or product managers where undocumented decisions are made.
So how does a reviewer handle that mystery? He can't just aggressively demand they delete the convoluted code if they're actually fulfilling a critical, albeit weird, requirement for the client.
He relies on the exact same mechanism he uses for de-escalation. The motive-free question.
A question again.
Always the question. When he encounters confusing or seemingly irrational business logic, he does not accuse the author of poor architecture. He asks a question completely stripped of judgment. Can you help me understand the requirement that led to this specific interaction?
It is a brilliant dual-purpose defense mechanism. By asking a neutral question, he builds an immediate escape hatch for the developer to reveal the hidden context.
Right.
The developer can reply, the product manager informed me yesterday that we have a major client still using 10-year-old hardware, so I had to write this convoluted workaround to prevent their systems from crashing.
Mystery solved.
Mystery solved. Cody understands the logic, the code is justified, and most importantly, Cody doesn't look foolish for aggressively demanding the deletion of a critical feature.
Exactly. But the inverse scenario is where the true value lies. What if Cody asks that motive-free question and the developer realizes they actually cannot answer it?
Oh, right. What if they blindly copy-pasted a requirement without understanding the underlying purpose?
Cody points out that if they can't articulate the why, it serves as a massive, unavoidable signal to the developer. It means their work is incomplete.
They have to pause a review, leave the screen, go back to the product manager, and demand clarity before the code could ever be merged into the main system.
It acts as stealth mentoring. By asking questions without an agenda, he protects his own credibility while simultaneously forcing junior engineers to take total ownership of their logic.
He is aggressively training them to never write a single line of code they cannot philosophically and practically defend.
Which is the mark of a truly great engineer.
Up to this point, the entire review process has taken place within the browser, skimming files on GitHub or GitLab. But occasionally, a pull request is just a monster.
A beast.
It touches 50 different files, alters core architecture, and changes the entire flow of the application. The browser is no longer sufficient. What does the process look like then?
That is when he enters the matrix.
The matrix.
The browser can only show you static text. For massive, complicated architectural changes, Cody pulls the code down. He physically downloads the entire branch onto his local machine and opens it in his integrated development environment, his IDE, which for Android development is Android Studio.
So he stops reading the code passively and begins interacting with it actively.
This represents a massive escalation in the review process. When reading fails to provide clarity, you have to execute.
He compiles the app. He clicks the buttons on the emulator.
But the core technical strategy he deploys here is setting breakpoints. And we need to dissect this breakpoint strategy because the underlying logic is universally applicable to auditing any complex, multi-layered system, whether it's software, a supply chain, or a legal contract.
A breakpoint is quite literally a digital stop sign you place on a specific line of code, right?
Exactly. When you run the program and the computer reaches that exact line, time freezes. The entire execution halts, and you can inspect the exact state of the machine, what variables hold what data at that frozen millisecond in time.
And Cody deploys these breakpoints layer by layer. He maps the vertical slice of the architecture.
He starts at the absolute top layer.
In Android, that is the activity or the fragment. Conceptually, this is the visual user interface, the literal screen, the buttons, the text fields the user's touching. He places a breakpoint there.
Then he descends one layer deeper.
Into the view model. This is the layer that holds the temporary data waiting to be displayed on that screen. Breakpoint there.
He goes deeper still.
Into the use case layer, where the heavy business logic dictates how the data is manipulated. Breakpoint there. Finally, he descends into the basement, the repository layer.
Right.
This is where the application actually speaks to the hard drive or reaches out across the internet to a server. Breakpoint there.
He is physically tracing the heartbeat of the data.
The heartbeat.
When the user taps a button on the screen, a pulse of data travels down through those specific architectural layers, hits the database, and a response travels back up the chain to the screen.
By stepping through the frozen breakpoints one by one, he is verifying if the reality of the machine actually matches the narrative the author wrote in the PR description.
Think of it like inspecting a sprawling house you're about to purchase.
Oh, I like this.
If you want to know if the house is structurally sound, you don't just stand in the living room, look at the fresh coat of paint, and say, "Looks good to me."
That's the browser review.
Exactly. If you want to know the truth, you have to trace the plumbing. You go upstairs and turn on the shower. You go downstairs and flush the toilet.
Then you physically walk down into the dark basement to ensure those pipes actually connect to the municipal water main, rather than just emptying raw sewage into a hidden crawl space.
Yes. You track the flow from the point of interaction to the final destination.
That grounds the abstraction perfectly. What he is specifically hunting for during this digital house inspection is what he calls a consistent path.
He uses the technical term unidirectional data flows.
UNIDs.
This means the data flows cleanly, logically, and predictably in one direction down to the basement and straight back up.
The plumbing is straight and easy to flow.
The enemy he is hunting for is spaghetti code. This is logic that completely ignores the architectural layers.
Just goes everywhere.
It calls over to a random file, skips the view model entirely, jumps down to the database, and then violently forces an update to the screen from the basement. It makes the execution path impossible to follow and incredibly dangerous to modify in the future.
And spaghetti code doesn't usually happen out of malice.
Rarely.
It happens because a developer was fighting a tight deadline, the architecture wasn't clearly defined, and they just brute forced a solution that technically worked, regardless of the mess it made in the walls.
They just needed it to run.
Right. So when Cody hits this spaghetti during his IDE deep dive, what is his recourse? He doesn't try to untangle the knot himself.
No, he reverts to the primary tool.
He goes back to the author and asks, hey, I stepped through this in the IDE, and why is this interaction jumping layers like this? Can you explain this flow to me?
He forces the chef to explain the chaotic recipe.
Taking a complex, tangled problem offline, pulling it out of the chaotic group Slack channel or the massive email thread, and sitting down in a quiet environment to manually map it out step by step is an incredibly pertinent strategy for any professional.
It really is. You map the flow of the project until you locate the exact point where the logic tangles into a knot, and then you ask a highly targeted, hyper-specific question to the person responsible.
Okay, so the code has been read, the unit tests have been audited for plastic soup, the architecture has been mapped in the IDE, the breakpoints have been cleared. Now, the final verdict must be rendered.
The moment of truth.
Cody has to actually push the button to approve or block the work. He provides a historical breakdown of his review outcomes over his career, and the distribution is fascinating. He calls it the 70-20-10 rule.
It provides a very clear window into the realities of software development. 70% of reviews are approved outright, 20% fall into a comment-only category, and 10% require request changes, which functions as a hard block.
The 70% approval bucket is the vast majority.
It is, but that massive approval bucket often includes dozens of minor comments and suggestions.
Oh, so it's not perfect code.
Not always. What elevates this process is that he explicitly tells the author, "I am approving this PR, so you are unblocked. I have left some thoughts and nitpicks, but please do not feel the urge to make these changes if you don't want to."
He intentionally removes the pressure.
He separates the critical, system-breaking path from the stylistic nice-to-haves.
That's refreshing. But the truly nuanced category in this distribution is the 20%. The comment-only zone.
Yeah, that zone is interesting.
This zone feels like absolute purgatory.
Hmm.
You aren't giving the developer the green light to merge, but you aren't pulling the emergency brake either. What exactly is the purpose of this middle ground?
It is a formalized acknowledgement of his own uncertainty.
Oh.
He is stating that he isn't entirely comfortable approving the architecture. Perhaps he lacks intimate familiarity with that specific dark corner of the legacy code base, or perhaps the author's approach is just fundamentally philosophically different from how he would solve the problem.
But crucially, he recognizes that the code is not objectively broken.
Right. It is not dangerous enough to justify blocking the team's momentum.
So he leaves his analysis in the comments, and then he completely defers to the collective. Standard practice requires multiple engineers to approve a PR before it merges.
By selecting comment only, he is essentially stepping back and saying, I have reservations, but I am removing my ego from the equation. If the other two reviewers look at this and feel confident, I will not stand in the way of progress.
It is the ultimate anti-gatekeeping maneuver.
E.
He does not need to act as the final boss on every single line of code shipped by the company.
Exactly. He trusts the collective intelligence and the democratic consensus of the engineering team.
But then we arrive at the final 10%.
The request changes bucket.
This is the hard block. The code cannot proceed to production under any circumstances until he is satisfied. What pushes a staff engineer over the edge to pull that lever?
His criteria for blocking a PR is highly pragmatic and honestly very primal. It is entirely driven by fear.
The fear of the pager.
Yes. He explicitly states, if they merge this, I will probably get woken up at 3 a.m. in the morning one day because the app is crashing.
That is the ultimate, uncompromising litmus test for senior engineering leadership. It is not about enforcing theoretical purity or punishing developers for stylistic differences. It is strictly about operational stability.
When he blocks a PR, he is generally absolutely confident that the code is legitimately dangerous, introduces systemic risk, and threatens the integrity of the live system.
But even in that extreme scenario, even when he hits the big red stop button to prevent a 3 a.m. catastrophe, he admits that he is occasionally wrong.
He does.
He notes that there are times he requests changes, utterly convinced the code is a ticking time bomb, only to jump on a Slack call with the developer, who calmly explains a piece of context he missed.
And in those moments, Cody has to swallow his pride and say, oh, wait, no, never mind. I was wrong. You were right. Go ahead and merge it.
Which loops the entire process perfectly back to the very first step.
The Grosch mindset.
Yes. You have to maintain the intellectual flexibility to admit you are wrong, even when you are the senior reviewer actively trying to protect the system. Your title does not immunize you from blind spots. And there is one final habit he builds into this framework, which isn't a statistical category, but it profoundly shapes the culture. He actively, purposefully hunts for code to praise.
It is a critical counterbalance.
Yeah.
If he learns a new trick from a junior developer or sees an incredibly elegant solution to a complex problem, he leaves a nice thumbs up comment. He explicitly states it's not a question, it's not a change request, it is pure, unadulterated positive reinforcement.
Which feels shockingly rare in professional environments. Usually peer review processes are entirely deficit-focused.
We are trained to only scan the document for what is broken, missing, or inefficient.
Taking the time to highlight what is clever fundamentally changes the emotional temperature of the review.
It serves a deeply strategic purpose beyond just boosting morale, actually. Contrasting the harsh reality of the 10% blocking with proactive public praise reinforces positive architectural behaviors.
It actively constructs that psychological safety we discussed at the beginning.
Yes. It ensures that future code naturally gravitates toward that 70% approval bucket because developers are highly motivated to write elegant code that earns the respect and praise of their senior peers.
Okay, so we've extracted the entire master blueprint from Cody Engel's 1,000 code reviews. You start by forcing a growth mindset. You aggressively resist the urge to rush, forcing yourself to read the underlying instructions, the PR description, and the unit tests before evaluating the work.
Right.
You deploy motive-free questions to disarm defensiveness and uncover hidden context. When the complexity overwhelms the browser, you pull the problem down locally and dissect it layer by layer to trace the absolute truth of the data flow.
And you dedicate yourself to elevating your peers to fluency,
while humbly accepting the absolute burden of persuasion. And above all, you leave your ego completely out of the equation, recognizing that even when you are terrified the system will break, a simple conversation might prove that you are the one who is wrong.
It is a remarkable battle-tested framework. And while it was forged in the fires of software engineering, the mechanics of slowing down, assuming positive intent, and tracing the structural integrity of an idea apply to absolutely any collaborative intellectual endeavor.
But as we close this out, I want to return to that one rule that completely rewired how I view teamwork. Cody states that if he cannot convince an author to make a vital architectural change, the failure is his own. It is his fault.
It forces a profound reevaluation of how we measure professional competence.
Think about the long-term historical trajectory of a massive project or a company or even a scientific field. If the objectively best, most elegant ideas constantly lose out simply because the person holding them possess poor communication skills, is the ultimate quality of our work actually determined by our raw technical ability?
Or is our entire technical output permanently capped by our ability to market and clearly articulate our ideas to our own teammates?
Right. If you cannot communicate the architecture never gets built. The communication is the work.
The communication is the work.
I want you to carry that thought with you the next time you sit down to review a colleague's work. The burden isn't just on them to execute it perfectly. The burden is on you to bridge the gap and clearly explain why a better way matters. Until next time, keep exploring.